gosh.
Oh.
Some CHEM1 alumni over there.
How long is that video?
10 seconds. All right. Welcome to your first lesson for CHEM1. We are starting off our unit number 1 titled Matter. If you do not have your notebooks out right now and your note-taking utilities, you are wrong. So let's go ahead and get those out. No. It's kind of centered with my whiteboard. I can't really move it. Is it in your way?
I mean, no, I'll be fine. Wow.
Is that better?
Yeah, actually.
Okay.
Move my neck.
I can't see from my corner.
Wait. Hurry up. Let's go. Ow.
Waiting on you, Isaac. Okay.
Do I stink?
Yeah.
All right. Hey, yesterday. Actually, before I even start that, for those of you who have never taken notebook notes before, you're going to learn to love them because that's all you do in this class. I do not give you guided notes. That is not the chemistry way.
Okay.
For your notes, I suggest always starting with the title. This is unit number 1, part 1. Matter classifications and properties is what I would start at the very top of your notes with. Hey, yesterday we briefly discussed what the definition of chemistry was. Does anyone remember what I said it was?
The study of change.
Yeah, well, that's the Walter White definition. The Walter White definition is that chemistry is the study of change. Do you remember the real definition that I said?
The study of matter.
The study of matter. Very good. But here's my question. What the heck is matter?
Something that takes up space.
Matter. Everything around us. Things that we can feel, but sometimes we don't feel it. Things that we can see, but sometimes we don't see it. We need a better definition than that. The true definition of matter is that matter can be defined. Oh, I'm going to sneeze. Thank you. Matter can be defined as anything that has a mass and takes up a volume. Anything that has a mass and takes up a volume. Mass we should be pretty familiar with. That is a biology term you use. That is a middle school term you use. Volume you may not have used for a little bit. Volume is how much space something takes up. Volume is how much space something takes up. Okay, we can determine volume in a few different ways. We're going to practice that here in a couple weeks. Are we all good on the true definition of matter? Hey, let's get some examples going. Hey, right here, my blowtorch. Is my blowtorch made out of matter?
Yes.
Yeah, how do you know? Well, it has a mass. It has a volume. An easy kind of picturesque way that you can determine if something is matter or not. If you can put it in a bucket, take it across the hall to Miss Atkins' room, and say, Miss Atkins, look in my bucket, look what I have. And she can actually see it. If I put this tissue in a bucket and I walk it over to Miss Atkins' room and I say, Miss Atkins, look at my tissue. Could she see it? Mm-hmm. It's matter. You can actually feel it's there. It has a mass, it has a volume. If I took a gas chamber, they're called vessels, a gas vessel, fill it with oxygen gas, and I say, hey, Miss Atkins, look at my vessel full of oxygen gas. Is it full of matter? Yes. It's got real stuff in it. There's matter inside it. But what about this? What if I take a bucket of light? Can I take a bucket of light over to Miss Atkins' room and say, hey, look at my light?
No.
No, why not?
Because we can't take light.
It doesn't have mass.
But watch. Am I not touching light right now?
You're touching
It's touching you.
You're obstructing.
Here's the thing. Light is an example of energy, not matter. Energy is not matter. Those are like the two things our universe is split into. Matter and energies. I can't just say bucket of light and take it to Miss Atkins. I can't yell in the bucket, Mr. Mead's the best teacher of all time, and take it to Miss Atkins' room and open the bucket and she'd hear the same thing, would she? No, it's impossible. That means sound. Is it matter or energy?
Energy.
Energy. What about heat? Energy. Do we get the picture?
Yeah.
Let's move on. Matter can be classified into two different ways, two different types. Hey, draw this T-chart with me. In the left-hand column, we're going to have the word pure substances. I guess it's two words, but you get the idea. The term. In the right-hand side, we're going to have mixtures. Those are the two categories that we can put any piece of matter into. But here's the thing, those aren't specific enough for me. I need to further break them down. Let's start with pure substances. Pure substances. Matter that's in its simplest form. When I say simplest form, what's something that you think of?
Air.
Think like a math.
Zero.
Like just 3 without any variables.
How about like fractions?
3/10.
Is 3/10 simplified?
Yes.
Yeah.
2/4.
No.
What can it be simplified to?
1/2.
Write what I write. If you want to read. Pure substances can be broken down into either being an element or being compound. An element. Hey, where do I get elements from in chemistry?
The periodic table of elements.
This wonderful map of elements right here called the periodic table. I gave all of you one of those yesterday. Every square on a periodic table is one element. Elements are the simplest type of matter in our universe. It does not get simpler than an element. Examples of elements, things like oxygen, hydrogen, helium, and they are always found on the PT, periodic table. Compounds, though, we haven't really touched compounds because it's day 2 of class. But you've been using compounds for the last 10 years of your educational career. There's a little bit left in here. What's in this bottle?
Water. H2O.
What is water's science name?
H2O.
H2O. Hey, H2O. What is that?
Hydrogen.
That's a compound. H2O is a compound. A compound, and write this definition, is made of 2 or more, so 2 plus elements. And they've been bonded together. Made of 2 or more elements bonded together. Hey, what 2 elements make up water?
Hydrogen and oxygen.
Hydrogen and oxygen. Hey, what's another famous compound that you...
Salt.
Salt. What's salt?
NaCl.
NaCl, good. What's another one? You breathe it out.
Dioxide.
Carbon dioxide. All of those are compounds, 2 or more elements. Glucose, C6H12O6. That is a compound. Sugar. Sucrose, table sugar. That is a compound. These are things that cannot be broken down any further. They are as simple as it gets in chemistry. That brings us to mixtures here. Mixtures can be separated. Mixtures can be separated. In a couple weeks, we're going to do a separations lab. We're going to learn how to separate 5 different, or I shouldn't say that, use 5 different methods of separation. But here's the thing, the term mixtures is not specific enough for me. It's not good enough. We further characterize mixtures as either being homogeneous or heterogeneous. For whoever just asked how do you spell that, it's right here and it's on the board. Hey, I bet last year in biology you used the terms homozygous and heterozygous. I want you to forget the word zygous ever existed. I don't care, that's biology, that's not my thing. I care about homogeneous and heterogeneous. Everybody say those 2 words, homogeneous, heterogeneous.
Homogeneous, heterogeneous.
Homogeneous, heterogeneous. Hey, quick English lesson. Homo means what?
Same.
Hetero means different.
Different.
A homogeneous mixture.
Same. 2 of the same thing.
No. A homogeneous mixture. Pay attention. Cannot see all of its components. A homogeneous mixture, you cannot see all of its components. Hey, there's a little bit of water that I have in here. I put a little bit of sugar in here. Could you see that sugar?
No.
No, it just looks like water, right? That's a homogeneous mixture. I've combined 2 compounds. I combined 2 pure substances. That makes a mixture. It is no longer simple. It's complex. I can separate water and sugar, right? I just boil the water away, and now I'm left with sugar and a bunch of steam. That's water. I can't see the sugar. All I see is water. I would never be able to tell the difference unless I drank the water. Do we get the idea of homogeneous? Hey, what's the biggest homogeneous mixture on Earth?
Water. Oh, shit. Salt water.
Ocean.
Yeah.
Air.
Air.
There's a lot of, I don't know.
But I will also accept salt water. Or sugar water, whatever. Let's talk heterogeneous mixtures. Different. In a heterogeneous mixture, you can see all the parts of the mixture. How many of you enjoy a good old snack of Chex Mix? I love Chex Mix. Cheddar Chex Mix specifically. If you bring me cheddar Chex Mix, I'll give you a point on your next quiz. Here's the thing in Chex Mix. It has the brown squares, the light squares, the yummy, crispy, flat bread, crunchy things, and then you have the nasty pretzels and breadsticks that nobody ever eats. They just get thrown away. Can you combine, if you have a bag of Chex Mix, could you not separate everything into its own pieces?
You did.
That's heterogeneous. You can see all of its components.
Salad.
Salad, good example.
Soup.
Chili.
Chili, good example.
Hot dogs.
Hot dog, bad example.
Everyone's hungry.
That's the worst example I've ever heard.
If I see a hot dog, all I see is a link. I can't really determine the chicken butt and the pork weenie. All right. Let's do some other examples. Oh, I need to take a 10 minutes. Skylar, it's your job to make sure I take attendance every day.
Gotcha, take attendance.
I am.
Perfect. I'm doing my job well.
Oh, does anybody not consent to being on video? I didn't see anything on Infinite Campus, but if you're not okay with being on video, now's your time.
I consent.
Okay.
Where's the video?
I would like to.
YouTube.
Oh.
You're a YouTuber?
Someone's missing. Oh.
On video.
Yes.
On video.
Isaac Elmore
Yes, sir.
is vanilla ice cream an element, compound, homogeneous mixture, or heterogeneous mixture?
Heterogeneous mixture.
He says heterogeneous mixture. Does anybody agree with
don't
him?
agree.
I disagree.
Why do we disagree?
You can't just take the
You
sugar.
can't see like all the milk and sugar, like you can't see every
Yeah.
single. Like,
Perfect.
visual.
So what is it? It's
a-
homogeneous. Exactly what they said. Ice cream is made out of salt, sugar, cream, vanilla, whatever else. Mix it all together, you get this beautiful ball of goodness. Can I take that beautiful ball of goodness and can I see milk, sugar, flour, whatever?
No.
Only if it's really, really bad ice cream. And if it's really, really bad ice cream, I don't want it. The answer for that one is homogeneous.
Beautiful.
June. Water. Compound, element, homogeneous mixture, or heterogeneous mixture?
Compound.
She says compound. Who agrees?
Me.
I agree.
Who disagrees? You disagree?
No, my bad.
I agree. Water is a compound. It's right here, H2O. It's made up of two elements. Yes, ma'am.
Okay, I was so close. I got to the last phase, where it asked for the substitute teacher password in the Zeit, and it won't take the substitute teacher's password. I was
Put an
so-
exclamation point at the end of it. Oh, wait. The password, it's 2016, not 2026.
Yeah, I did both of them.
Oh.
Yeah, that's okay. It was close, so I don't know what. Yeah.
I'll look at it in a
Okay,
little
and then
bit.
I've got these two gals, and they were patiently waiting for me as I did this, and I know two people aren't supposed to go to the restroom at the same time.
Who is it?
Well, they're totally embarrassed.
Bro, walk in here or I'm not accepting it. Who are you?
Say your name, it's okay.
Oh, Eliza?
Eliza and Parker? I don't see either one of you on here. I didn't even have a pass to accept for you. Did you do it on your laptops, on your Chromebooks?
Yeah, it's my fault. It's my fault.
No, you're fine.
I thought I was gonna be able to do it from my computer.
No, it's fine.
Okay, but it's Eliza. Oh, I'm so mad because it was so close and I cannot see.
When I see it, I'll push it.
Anyways, okay, thank you.
Yep.
I apologize, friends.
No, no problem. All that's going in the video. I don't edit anything out. So if you get to this point in the video, you can just fast forward a few seconds. Where was I at?
Do you publicly post this?
Huh?
Do you like publicly post them?
Yeah.
How many subscribers?
I think there's like 50 right now. I don't know.
Let's blow Mr.
All right, Mr. Hickey. Chlorine, element, compound, homogeneous mixture, or heterogeneous mixture?
I'm gonna have to say that's a homogeneous mixture.
He says homogeneous mixture. Who
I
agrees?
disagree.
I disagree.
What do we disagree for?
It's an
It's an
element.
element.
Element. What element is it?
CL.
Cl, element 17 on the periodic table. It has a mass of 35.45 atomic mass units. Has 17 protons, 17 electrons, and 18 neutrons. It has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p5. What's up?
You can tell me the mass number for every element on the periodic table.
Probably like the first 36 I could. You'll learn everything I just said, you will learn eventually. You don't have to memorize it, you're just going to learn how to find it.
Why does it say Krypton up there?
Because we just don't go that far down.
Krypton was a planet.
Hey, Gretchen. Hey, fruit salad. Homogeneous, heterogeneous, compound, or element? Huh? She says heterogeneous. Do we agree or disagree? I agree. I agree with heterogeneous. 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 All right. Do we feel good with this stuff? Let's move on to properties now.
Heterogeneous, bro.
It's heterogeneous.
No, it's not.
I promise it
I
is.
spent my whole life saying heterogeneous.
It's heterogeneous.
Jonathan, I disagree.
You can disagree all you want, but the dictionary is going to disagree with
We're
you.
making another T chart.
Yes, we are going to make another T chart. Yes, sir.
What were the four things? Ice cream, water,
Ice cream.
Right there.
I don't remember.
Ice cream, water.
Ice cream, water, chlorine, fruit salad.
That's sick. Excuse me.
Can I erase this T-chart?
Yep.
Yes.
All I do is win, no matter what.
The only thing you're winning is an extra homework assignment tonight.
Oh. I'm just kidding. I love you, Kevin.
All right, our next T-chart will be titled properties.
What? What are you saying?
Hey, are you missing anything there, pal? Are you missing anything? Just wondering.
Missing what?
We have extensive properties and
What is he
intensive.
asking? I'm trying to show you.
I did.
Oh.
Sorry,
Wait, where'd you have that?
On your desk, bro.
Where'd you take
Grabbed it before the class even started.
it.
Had that the whole time.
Bro, wait, so you guys tell me. I tried to. Okay, I was wondering why you're squeezing my hair. I was like, what?
All right, extensive versus intensive. Extensive properties.
Holy crap, Skylar.
Woo, that wasn't me, bro. Quit. You
Bro.
know.
I don't even have any. Do I have any Febreze?
You should probably buy it. Can you use that gas? No, please put that back.
I got some disinfectant.
Pretty bad. All right, it wasn't me. You know it was you. Oh, everything it was not me. Everything is God.
And I thought the gummy bears smelled bad. Good Lord. All right. Extensive properties. Extensive properties. Characteristics that change with the amount of matter you have. Extensive properties change with the amount of matter you have. Intensive properties, on the other hand, do not change based off of the amount of matter you have. Intensive properties do not change based off of the amount of matter you have. Hey, look up here. Look at this sheet of paper. It's a standard notebook paper. Do we agree?
Yeah.
Hey, what color is this paper?
White.
I just added more matter. What color is this paper?
White.
Hey, I just added more matter. What color paper is it?
White.
Is my color changing even though I'm adding matter?
No.
Is that extensive or intensive?
Intensive.
Intensive. Good.
Are we saying the paper is intensive or the color?
Color is intensive.
Okay.
You could read this.
Hey, look at my paper. Look at my paper. We're going to say this weighs 1 gram. Now how much does it weigh?
Extensive.
Now how much does it weigh?
3 grams.
Now how much does it weigh? Is my mass changing when I add matter?
Yes.
Is mass extensive or intensive?
Extensive.
Mass is extensive. Hey, look at my paper. Look at how much space it takes up. Am I taking up more space?
Yeah.
Am I taking up more space now?
Yeah.
Extensive or intensive?
Extensive.
Hey, the amount of space something takes up, what's that called?
Volume.
Volume. Volume is extensive. Hey, look at my paper. Look at my paper. Look at my paper. Hey, look how long this is. Do we see how long it is? Watch what happens when I add more matter. Does it get longer?
Yes.
Is length extensive or intensive?
Extensive.
Extensive. Hey, I want us to notice something. Hey, isn't it really easy to calculate or to determine mass in the lab?
Yeah.
I just go back there and put something on a scale and it'll read the number, right? Hey, volume, isn't it really easy to tell volume of something?
Yeah.
I use a graduated cylinder or a beaker or any glassware and I just tell the volume, right? Easy. Length, isn't it really easy to measure length of something? What do I use? A freaking ruler or a meter stick. How do I measure color?
The amount.
Rainbow?
Is there any tool back there that I can use to just measure color?
No. Color wheel.
Extensive properties. Write this down because I guarantee I put this on your test. Extensive properties are very easily measured in lab. And hey, first period, I didn't say that during your class, so I hope you watch this video so you get that when I put it on your test.
I just got
Or intensive properties. Intensive properties can be looked up in a book. They do not change based off of the amount. One of the most famous intensive properties is melting point and boiling point. Yes, sir.
Why'd you look straight at me?
Melting point and boiling point. Hey, here's what I mean. Hey, does anybody know what temperature water boils?
212.
212 degrees Fahrenheit. Anybody know what that is in Celsius?
100.
100 degrees Celsius. Hey, it doesn't matter if I have a whole bathtub full of water or a little bit of cooking pot. If I have both of those things of water at 85 degrees, is any of the water going to boil? No. But as soon as either one of them, no matter how much water is in it, hits 100 degrees Celsius, some of it will start to boil. I can look boiling point and melting points up in a book. That's what makes them intensive. Another thing that I can look up is density. Does anybody know the math formula for density?
Volume.
Mass divided by volume. Hey, look! I've got mass over volume on my chart right here, right? Do we see extensive property mass, extensive property volume? Yes. Write this down somewhere. When you divide two extensive properties, you make an intensive. When you divide two extensive properties, you make, or your result will be an intensive, like density. Densities can be looked up in a book. Water is the standard. Water has a density of 1.00 grams per milliliter. If something has a higher density than water, it sinks. If something has a lower density than water, it floats. We're going to have a whole another chat. We have a whole lesson over density next unit. So that's all I'm going to say about density for now. I just need you to know density is intensive.
So when you divide two extensive, you get intensive.
Yes. Kind of like a negative divided by a negative is a positive. An extensive divided by an extensive is an intensive. Cool? Say no.
Yeah, I'm just kidding.
All right. Let's talk about changes. Because I also said that Walter White says that chemistry is
The study of change.
study of change. Let's talk about changes. There's two types of changes. Chemical changes and physical changes. We're done with T-charts, by the way.
Wait, so is this the last slide? 'Cause- No.
There's three more, but it's just this one. It's this one, then some examples, and then the last slide is literally just one sentence. You'll fit everything there. I promise.
I mean, I've already used.
Do you, boo?
How many spaces? Okay.
There's two types of changes. The first type is physical changes. Physical changes are the common changes. These are the things that you probably do all day long. When Skylar finally realizes that his hair does not look good, he's going to go home and shave his head. He's going to look like me. But here's the thing. When he shaves his head, was a new substance formed? No, just his shiny baldness. Will his hair regrow?
Yes.
It's reversible. That's an example of a physical change. If I throw a rock through my window right there, what happens? The glass shatters.
And now you have more.
Was there a new substance made?
No.
No. It's still a glass. Can't I just get all that glass, melt it down, and then make my window back?
Yeah.
I mean, I can't. I'm not good enough like that, but I'm sure somebody could. Physical changes alter appearances, but nothing new is made. Compared to a chemical change. In a chemical change, new substances are formed. In a chemical change, new substances are formed. These changes are often not reversible unless you do another chemical reaction. Hey, look at my paper right here. I'm going to do a series of changes to this paper, and I want you to tell me chemical or physical, okay?
Oh.
All right.
All right, y'all ready? Here's my paper. Here it is. It's all shiny and new. Chemical change or physical change?
Physical.
Was a new substance made? We know it's physical. Hey, isn't it reversible too? Yeah, I just did. Look, it's back to its full sheet. Hey, chemical or physical?
Physical.
Physical. Was a new substance made? No. Can I put it back to its original?
Yes.
I could use tape. It wouldn't be perfect, but it's okay. Chemical or physical?
Chemical.
How do you know it's chemical?
It's a new
Can't bring it
substance.
back.
I can't bring them back. It's a new substance being made.
Yeah.
Yeah, what is it? Ash. What else?
Flame.
Smoke.
Smoke. There's smoke being formed. You can kind of see it now that it's kind of out. Was there smoke before I lit it on fire?
No.
Was there ash before I lit it on fire?
No.
A chemical change occurred. New substances were formed. I can never turn that ash and that smoke back into paper. Do we make sense? Are we okay with chemical versus physical? Let's do some examples. Let's see, who am I going to call on? I already called on you, Bozo. Dennis!
Yeah.
Glass breaking. Physical or chemical change? He says physical. Do we agree?
Yes.
I agree. Hey, Maggie. Bike chain rusting. Chemical or physical? She says chemical. Do we agree?
No.
Can I reverse a bike chain rusting?
Yes.
No.
WD-40.
There's a new material.
WD-40. Hey, but is WD-40 just some magical goop that just fixes it?
Yeah,
It's another chemical. It's doing another chemical reaction. A bike chain. Hey, listen to me, losers. A bike chain rusting is a chemical change. Good job. Coop. Ice cube melts. Chemical or physical?
Physical.
But are we getting a new substance? We're making water.
No, it's still same. It's still H2O.
Ice is just frozen water, right? For some reason, high schoolers like to believe that when ice melts, we get water, but it's just something brand new. It's just new water. Spoiler alert, ice is made out of water. I know, crazy concept. Physical change, I agree.
Low key.
Last but not least, June, have I called on you yet?
Yes.
Jimmy.
Kenley, baking a cake.
What's that? Just kidding. Sorry. Chemical.
Heterogeneous.
She says chemical, do we agree?
Yeah.
Hey, if I bake a cake, I have to mix flour, eggs, and sugar, milk, whatever. Once I put that in the oven, it bakes for 45 minutes. I pull it out. Can I get my eggs, milk, and sugar back?
No.
No. My cake is cake. Cooked. Barbecue chicken. Are we good?
Not really.
I got one slide left, and then we're done for the day. Viscosity.
Yo, I know about this.
Viscosity is my last vocab word for today.
Ooh, I might
Viscosity refers to a fluid's resistance to flow. What does that mean? Does something flow fast or does something flow slow?
It flows slow.
Hey, water. Would you say water? Look at how this water flows. Would you say it's flowing pretty fast, pretty slow?
Pretty fast.
Pretty fast. I would describe that as viscous or not viscous? Not viscous. Low viscosity. Maple syrup. Sticky. Syrupy. Pours slow or pours fast?
Slow.
Pours very slow. High viscosity, low viscosity.
High viscosity.
High viscosity. Viscous or not viscous?
Viscous.
Viscous. How do we feel? Hey, give yourselves a round of applause. Just finished your first Chem 1 lesson. Peace out.